Alright guys, so for this week's lab, we're going to be learning how to draw Lewis structures. We haven't quite finished that in lecture yet, so I'm going to have to give you a little heads up in the lab part of it. So this is basically going into chapter 10 right now, so the notes for this one I will post when we hit chapter 10, but this will be, I'm going to give you guys enough so you are able to build the Lewis structures. So we're going to talk something about valence electrons. That's what we really need to know. So here I've got the periodic table, and we'll talk about what really are valence electrons and how they come about towards the end of chapter 9. Hopefully by the middle of this week we should reach valence electrons. But in order to build Lewis structures, you need to know how we can determine valence electrons from the periodic table. Now there's an easy way to do it. So for now, just kind of take my word for it, and so that you're able to complete the lab. The very last column right here, I'm going to begin with that. This column has 8 valence electrons with the exception of helium. Helium has only 2. Okay. Fluorine column, the halogens, these guys have 7 valence electrons. The oxygen column had basically oxygen, sulfur, selenium, they have 6. The column has 5, so nitrogen, phosphorus, arsenic. Carbon has 4, boron, aluminum has 3. Okay, and then when it comes to this side right here, your alkali earth metals, these guys have 2, and your alkali metals have 1. Okay, so for now, just kind of, like I said, go with the flow. Basically, the valence electrons are the electrons that are found in the outermost shell of an atom. And you'll see what I mean by that when we start talking about shells and how the electrons are distributed within an atom itself. Okay, these are the electrons that are involved in bonds when bonds are being made. So that's why they're important. Okay, so if you have, let's say, an atom such as this one, right, with a nucleus, positively charged nucleus, we have different shells. So they're kind of like concentric circles, but not quite, but this just kind of helps you understand the picture. So let's say these are the different shells that the electrons are found. The first shell contains a maximum of 2 electrons. The second one can contain a maximum of 8 electrons. And then the third one can contain a maximum of 8 electrons, and so on and so forth. Okay, so each shell has a certain capacity, and the outermost shell is where these valence electrons are found in each of the atoms. All right, it's kind of like, think of an onion, the outermost layer of the onion, whatever electrons are in that one, those are the electrons that are basically involved in bonding. Okay, so we're going to start drawing our Lewis structures. So the first thing I want to ask you guys is, if I told you I have an atom lithium, how many valence electrons does this have? And going by what I told you, you would determine that lithium has 1 valence electron. Okay, so how would you show this in terms of pictures, like actual drawing? We would take the symbol for lithium, Li, and doesn't matter which side you pick, each side of the atom, the symbol has 4 sides. Well, there's 4 sides to the symbol, so you would basically just draw a single dot, which represents an electron. Okay, so dots represent electrons. Now, if I was to ask you for nitrogen, how many valence electrons does nitrogen have, a single nitrogen atom? You would look at the chart and you would be like, okay, there's 5 valence electrons in nitrogen. How would you draw the distribution of these 5 electrons around nitrogen? So you would write the symbol for nitrogen. Let's count. Okay, so 1 electron on each side of nitrogen. 1, 2, 3, 4, and now the 5th one is when we pair up one of those electrons. Doesn't matter which one you pair up, but you must distribute those electrons on each side of the symbol first. So each electron has to be single first before you can start pairing them up. Okay, let's try another one. We'll do oxygen. Okay, how many valence electrons in oxygen? We have 6. So how would you draw the distribution of these electrons for 6 electrons around oxygen? 1, 2, 3, 4. Now each side has a single electron. Now I'm allowed to start pairing them up. 5 and 6. Okay, so 2 pairs of electrons, and then 2 of them are basically single electrons around that oxygen atom. Okay, so these symbols that I have drawn, this one right here for nitrogen, this one right here for oxygen, this one here for lithium, these are called Lewis symbols. Okay, so they basically allow us, Lewis structures, when we start building them, they allow us to kind of predict the structure of a molecule. Okay, so we're going to start building some molecules now. All right, so first things first, I would like us to make some ionic compounds. So just a quick definition of ionic compounds. Ionic bonds, that's what our ionic compounds are made up of. And ionic compounds, basically you have a metal plus a non-metal. Okay, and remember, metals are your cations, so they have a positive charge on them, and your non-metals are your anions that have negative charges on them. Okay, so for example, sodium plus Cl minus, these two, when they combine together, they will give you an ionic compound, which we know as NaCl. Okay, but now if we were to actually draw this out, how would we do it? So first we would take sodium. How many valence electrons does sodium have? You can go back and check. Sodium has a single valence electron, so you can draw it like so. And then chlorine has how many valence electrons? 7. So 1, 2, 3, 4, 5, 6, 7. Okay, so 7 valence electrons. Well, now these are basically neutral atoms right now, but the whole point, in order for these to make an ionic bond, that means one of them has to become a cation, the other one has to be an anion, right? So they are not cation and anion just yet. So what happens is this single electron on sodium basically goes over to the chlorine. So it'll come right here. Okay, so now chlorine has an extra electron on it. And what happens is chlorine gets a negative charge. Sodium lost the electron that it had, so sodium now has a positive charge on it. Now, because there's a positive and a negative charge between two atoms, they get attracted to each other, and they would basically make sodium chloride, where your electrons look something like this. Okay, and sodium is obviously, because of its positive charge, that's why it is in the vicinity of the chlorine anion. Okay, let's try another one with an ionic bond. I would like us to try Mg, making a magnesium oxide ionic compound. So pause the video, determine how many valence electrons does magnesium have, how many valence electrons does oxygen have, and then basically show me the transfer of those electrons, and then you can determine which one has a positive charge, which one has a negative charge. All right, so with magnesium, valence electrons with magnesium are 2. So 1, oops. Okay, so 1 and 2. Oxygen has 6 valence electrons. So 1, 2, 3, 4, 5, 6, right? And in order to make a bond, magnesium we know has a positive 2 charge, right? That means 2 of those electrons have to be gone. And on the same side, oxygen has a 2- charge. That means oxygen has to gain those 2 electrons. So this electron and this electron is going to move to the oxygen. And this one, okay, I'm going to draw the other way around. Actually, it'll be easier. What if I did this? Okay, it doesn't really matter. I mean, they're electrons at the end of the day. They're all just going to go all together. But this is just to show you. Okay, so that electron came here. So magnesium lost its 2 electrons. So magnesium has a 2+ charge. Oxygen gained those 2 electrons. Oxygen gets a 2- charge. And this basically gives us MgO with 8 electrons around oxygen. Okay, it's not that magnesium doesn't have any electrons, it still does, but in terms of its outermost shell, it doesn't have any more. Okay, so these are still all just the valence electrons. We'll do one more and then we'll move on. Let's do sodium sulfide, Na2S. Okay, I'll write it down here so you guys can pause the video, try it out on your own first, and then come back to it, and then you can see what we're doing. Okay, so sodium has 1 valence electron. Sulfur has 6 valence electrons, so 1, 2, 3, 4, 5, 6. Okay, sodium we know has a charge of +1, so it can only give up a single electron. So it's going to be that single electron right here. This one's going to go to the sulfur. So this sodium, oops, sorry guys. So this sodium is going to lose 1 electron and the sulfur is going to gain it. All right, but we know sulfur has a 2- charge, right? And we know from the formula that there should be 2 sodiums. Well, we can draw another sodium with another electron, valence electron, and that sodium can give up its electron to sulfur. Okay, so each of the sodiums now end up with a +1 charge. And the sulfur gained 2 electrons from 2 different sodiums. It has a 2- charge. And this gives us Na2S. Okay, so this is basically the formation of ionic compounds. Now, Lewis structures are not the best when it comes to drawing ionic compounds. You can show the formation of these simple ionic compounds with Lewis structures, but the more complicated ones is a much different story, which we're not going to get into. So in the next video, we'll talk about molecular compounds and how we're going to build those molecular compounds using these Lewis symbols. All right, so be prepared for that.